So in the previous video we saw how to frame the symbols of the compounds. So as I told you earlier that we can consider them to be the 2 letters and 3 letter words of the language of the chemistry. So yeah, we learned first the alphabets with the plus and the 1 plus and 2 plus and 2 minus, all the valencies over there. Then we saw that how these valencies are combining with each other to give rise to the formation of a symbol of a compound. इसीलिए हम लोग को ZnCO3 और वगैरह वगैरह सब बना अलग अलग टाइप का. And now we come to the next part, and that is the sentence formation in case of chemistry. That is, you are now going to frame the chemical equation. So the chemical equations can be compared to the sentence formations in case of any language you are learning. So here the chemical equation, the term is, the chemical equation is a shorthand form representing the result of a chemical change. So whenever there is a chemical change which is going to take place, there will be 2 stages. First stage is the reacting stage or the reactants. The reactants are the one which are going to combine with each other, react with each other in some conditions, and accordingly there will be a result over there. The result are called as the products. So the equation, any chemical equation has got 2 sides. The left hand side, so there is an arrow in between, so always it will be this way. There will be an arrow in between. This side is the reactants, and after the reactants have reacted, what is formed are the products. So the left hand side is the reactants and the right hand side are the products. Okay, so the one which are going to react are called as the reactants, which are to the left hand side of the chemical equation, and the one which are going to be formed after the reaction are called as the products, which are written in the right hand side of the chemical equation. So that's why we call the equation to be a shorthand form of a chemical change which is going to take place. So the left hand side, write the reactants, that is substances which take part in the chemical reactions. Those substances which take part in the chemical reactions are called as the reactants. For example, dilute sulfuric acid and zinc. So what we are given over here is zinc reacting with dilute sulfuric acid. Now based on our previous videos, we know that how do we name these things. So zinc, I know it's an element, so it will be just Zn. And sulfuric acid, we have learned from that table that it is H2SO4. So it is the H2SO4 which is in dilute nature. So I'll just need to write over here dilute in this form. So this is zinc and this is sulfuric acid which is going to react. So on the right hand side, what we have are the products. So when these two are going to react, there will be some reaction and there is going to be formation of a new compound by a chemical change. So the right hand side, write the products, that is substances formed as a result of the reaction, and as a result of the reaction what is going to be formed will be over here is zinc sulfate plus hydrogen. So now we know zinc is nothing but Zn. So I'll just write down over Zn, which has got a valency 2, and SO4 has got a valency 2. So it gets cut. So that's why zinc sulfate will be ZnSO4. And hydrogen, I told you that it's a divalent compound, so it's always going to be H2. Okay, it is the atomicity of hydrogen is 2, that's why it will always be written as H2. So that gives me the chemical equation: reactant side, product side, zinc plus sulfuric acid, giving me zinc sulfate plus hydrogen. So the one which we have written over here, this is called as the word equation. This is the word equation, and this is called as the molecular equation. So this is the molecular equation and this is the word equation. So when you are writing everything in words, it is a word equation, and when writing everything in symbolic form, it is the molecular equation. Now, what are the limitations and the information what we get from this particular kind of equation? So, of course, we first need to know that what are the things we are going to get, or what are the things which we are going to achieve by writing a particular chemical equation. And at the same time, is that chemical equation completely like it has got everything in it? No. Then what are the things which it is not going to tell me? And if it is not going to tell me, what is the method by which I can add to that particular equation so that more information which I require from the equation can be gathered. So let's see one by one. Let's see what are the informations provided by the equation. So the chemical equations, after covering the limitations given alongside, tells us about first formula and symbols of the reactants and products. Of course, it tells me the formula of the reactants as well as the products. So it is giving me all the formula of the reactants and the products and the symbols of that. Secondly, the physical state of the substance, whether it is solid, liquid or gaseous. Like for example over here, I can write over here as S like this. I can write over here G like this. So I know that this is solid, this is going to be gaseous. So I can give the matter का जो state है, the state of the matter I can always mention as S, L, L liquid, G and a gas. I can always write those things in the brackets along with the substance. So whether it's solid, liquid or gases can be easily mentioned over there. Third, can show the special conditions required for the reaction to take place, such as heat, catalyst, etc., and show directions of reactions. So the arrows over here are not just a simple arrow to tell that this is going to form this. Arrows can also be used in a way कि वो arrow के ऊपर हम लोग कुछ ना कुछ लिख सकते हैं. Like for example, if I write a triangle over here, it means that I am going to heat it. Suppose arrow के ऊपर मैंने यहाँ पे लिख दिया, like if I tell over here nickel, उसका मतलब है nickel is going to be the catalyst in this particular reaction. So I can write the catalyst over here over like this. I can also mention the temperature like 300 degrees Celsius, 2 atmospheric pressure. The temperature and pressure conditions can also be mentioned in this particular kind of arrow. So yeah, you can write this way. Another thing is that some reactions are such that if I reverse the conditions, समझो मैंने किसी को जो heat किया तो वो दो पार्ट में डिवाइड हो जाएगा और उसके बाद उसको कूल किया तो वो फिर से अपने आप में आ जाएगा. So such a kind of thing is going to tell you the direction of reaction. That is, it can go not only one way but two ways. So that means it can be like, the arrow could be like this as well as like this. This is called as a reversible reaction. A reversible reaction is the one which can happen on both ways. So the reactants becomes a product and the products on reversing the condition become again the reactants. So the products are now the reactants and form into a product which is original reactants. So that's why it is called as a reversible reaction. So examples over here is HGO on heating, that is a triangle gives you the heating part over here, that is triangle gives you Hg plus O2 where triangle means heat required. KClO3 with the arrow के ऊपर MnO2 लिख दिया means MnO2 is the catalyst required. Fe plus H2O and then you have reversible sign, that means Fe plus H2O will give you Fe3O4 plus H2 and Fe3O4 plus H2 will also give you, if the conditions are reversed, it will give you Fe plus H2O. So the above equations have to be balanced. Of course, what is balancing I'll tell you in the later part of the chapter. And the fourth part is the balanced equation tells us in what ratio the substances react or are produced. So This is very important. We'll talk about it when we understand the balancing that, or I'll just give you a small example over here. So if I am saying, like for example, if the formation of ammonia N2 plus H2 gives me NH3. Now this is not the right equation, because here there are two atoms of nitrogen, only one atom of nitrogen. There are two atoms of hydrogen, gives me three atoms of hydrogen. अभी यहाँ पे ना मैं हाइड्रोजन जनरेट कर सकता हूँ, ना मैं नाइट्रोजन को डिस्ट्रॉय कर सकता हूँ. Okay, so what is to be done? I need to solve it in such a way that if I put a 3 over here and a 2 over here, automatically now what happens? There are two nitrogen are 2, hydrogen are 6 over here, and hydrogen over here is also 6. So what I have done is called as balancing of equation. With this, what will happen is that I know over here that 1 volume of nitrogen will react with 3 volumes of hydrogen to give me 2 volumes of ammonia. So the balancing of the equation tells me that what are the ratios in which the reactants are going to be used and what will be the ratio in which I am going to get the product. 1 volume of nitrogen, when it reacts with 3 volumes of hydrogen, I will get 2 volumes of ammonia. Got it? So this way, the balancing tells us that what is the ratio in which the substances are going to be reacting and are going to be produced. So these are the things what you can get to know from a particular equation. Okay, the fourth thing what you are going to learn from the equations is the state of the matter, that is solid, liquid or gases. You can know the symbols and the reactants of the reactants. You can add whatever you want on the arrow part to tell you the heat and the catalyst or whatever you want. And you can also know by the balancing that what is the volume of the reactants and the products you form. So there are some limitations to this thing. The chemical equations suffer from a number of limitations and do not tell us about first physical state. Now this, of course, it doesn't tell you the physical state, but of course we are able to overcome this thing by putting the S for solid and G for gas and L for liquid over here. So the reactants and products, but hence S for solid, L for liquid and G for gas or vapors for vapor are maybe added. So this, of course, you can eliminate. This limitation you can still eliminate without any problems. The second is the conditions such as temperature, pressure, catalyst which affect the reaction. Of course, again, this can be mentioned over here on the arrow. So it was a limitation earlier, but now we have overcome that limitation by writing those conditions required for the reaction to take place on the arrow over there. तो arrow के ऊपर हम लोग catalyst का नाम, temperature कितना है, pressure कितना है, वो हम लोग लिख सकते हैं, and accordingly we can overcome this particular limitation. The concentration of the reactant and products. So again, we don't know whether it is concentrated or dilute, but again we can write in this form. You have got written over here dilute. You can write concentrated also. So accordingly, so you can write over there the concentrated dilute in the reaction and overcome the limitation of the equation. So hence in some cases dilute, that is DIL for dilute and CONC for concentrated may be added. Fourth, the nature of the chemical reaction. Now this cannot be known. What is the nature of the reaction? What is the nature of the reaction which is going to take place? Whether it is going to be reversible, तो reversible फिर भी वो irreversible, but whether it is going to be with the help of a light या क्या होगा, तो वो nature यानी it is displacement, double displacement, बहुत सारे natures होते हैं, different types of reactions. So the nature of the reaction cannot be known by the equation. Next thing I cannot know is the speed of the reaction. I know that this is going to happen, but it is going to tell me, will I be able to know that whether it is going to take place in 1 second, or it is going to take 1 minute, or it is going to take 1 hour? So what is the speed at which this reaction is going to take place? That is not known. That cannot be even identified, or that is a limitation which is still persisting in case of the equations. You cannot know the speed of the reaction. 6. The heat changes accompanying the reaction. There may be heat changes which is taking place. So some absorb heat, some give out heat. So वो heat changes जो absorption होगा या evolve होगा वो that cannot be given in the form of the equation. And lastly, the completion of the reaction. The reaction may or may not be complete and the reaction does not reveal it. So whether ये होने के बाद में ये और आगे react करेगा कि नहीं करेगा, whether the reaction which is going to take place is going to be complete or incomplete. It may happen that this ammonia react with hydrogen further and give you something else. Right? So you don't know that whether this reaction which is going to take place is a completed one or it is still in process. It will proceed further and give you something else. That you don't know about that part. So that still remains a limitation. So the three most important limitations which are still going to retain or remain is you don't know the speed of the limitation, speed of the nature of the reaction, the speed of the reaction, and mainly you are not able to know whether the reaction has got completed or it is halfway or it is going to be proceeding further. So that's the limitations of the chemical equations. Now we can see the next thing, and that is chemical equations can be of two kinds. One is a balanced equation and the other is an unbalanced equation. Of course, you are not going to use any unbalanced equation. Unbalanced equations can be written only in the form of a word equation. Word equation is never balanced, it's an unbalanced equation. But all the molecular equations will always need to be balanced. If you are writing any equation which is not balanced, even if everything is correct over here, you will get a 0. So each and every chemical equation, whenever you are writing it, will always be required to be balanced. So balancing the equation is the most important part. So what is a balanced equation? It is one in which the number of atoms of each element of the reactants is equal to the number of atoms of each element of the product. That is, number of atoms of each element of the electron of the reactant is equal to the number of atoms of each element of the product. See over here, what happens is, we very well know that matter can neither be created nor be destroyed. So I gave you this example over here, N2 plus H2 giving me NH3. So what has happened? I just initially wrote it this way. And I told you that I cannot keep this as it is. Why is it so? Because in this equation what I have done is that I have removed one of the nitrogen and I had removed one of the nitrogen and I added one hydrogen over here. Now that means this reaction had the capacity to generate matter. It had the capacity to generate nitrogen. Sorry, it had a capacity to destroy one nitrogen and generate one hydrogen. But matter can neither be created nor be destroyed. So that means writing this equation as it is wrong. Another thing is that I can see over here that on writing this equation, the number of atoms of nitrogen over here are 2 and number of hydrogen atom are 2, but whereas over here nitrogen is only 1 and hydrogen is 3. That means that the number of atoms of each element on the reactant side and the product side is not the same. So in such conditions, I will need to add some numbers over here such that the number of atoms on the reactant side and the number of atoms on the product side of both the elements over here will become equal. So for this, what we are going to do is we are writing a N2 plus H2 giving me NH3. Nitrogen, so over here we have the nitrogen to be having 2 electrons over here, whereas there is only 1 electron here. Hydrogen is only 2 electrons here and only 3 over here. So what we do is that to make this into 2, I will need to multiply this by 2. So because if I multiply this by 2 means I have got 2 times ammonia. 2 times ammonia means 2 nitrogen and 6 hydrogen. So that's why this will be multiplied by 2 to make this 2 and this becomes 6. So now nitrogen has become 2 and 2 equal over here. Accordingly, if you see, nitrogen तो clear हो गया, पर hydrogen यहाँ पे 6 है और यहाँ पे 2 है, So I need to put a 3 here so that this will multiply by 3 to make it 6. So now this is also 6 and this is also 6. So this is called as a balanced equation, wherein the number of atoms of nitrogen on the reactant side and the product are same. Number of number of hydrogen atoms in the reactant side and the product type is also the same. Thence we call such a kind of a reaction as a balanced equation. So in the reaction Zn plus H2SO4, they can see Zn is over here 1, over here is also 1. Hydrogen is 2 over here, hydrogen is 2 over here. S is once, S is once, O is 4 times, O is 4 times. So this is a balanced equation. Because you don't need to add any number over here, this is called as a self-balanced equation. It is called as self-balanced. This equation is self-balanced, means you don't need to balance it you don't need to balance it because it is already balanced. Okay. So 1 atom of zinc and 1 atom of sulfur, 2 atoms of hydrogen and 4 atoms of oxygen. There is a number of atoms of each of the are in reactants. And similarly 1 atom of zinc, 1 atom of sulfur, 2 atoms of hydrogen, 4 atoms of oxygen, which is the number of atoms present in the products. So therefore the above reaction is a balanced equation. An unbalanced equation is one in which the number of atoms of each element of the reactant is not equal to the number of atoms of each element of the product. For example, Zn plus HCl will give you ZnCl2 plus H2. So you can see zinc is only 1, whereas the other side the zinc is 1. But chlorine over here and hydrogen over here is only 1 1 each, whereas they are 2 2 each in case of the product. So you can see, since the number of atoms in the reactant sides of each element is not equal to the number of atoms of the product side, that's why it is an unbalanced equation. So the equation Zn plus HCl giving me ZnCl2 plus H2 is an unbalanced equation. So why do we balance it? The reason is that an equation must be balanced to comply with law of conservation of mass. What was the law of conservation mass? Matter can neither be created nor be destroyed. So law of conservation mass, that is, in course of chemical reaction, matter is neither created nor destroyed during the chemical change. So in a balanced equation, total mass of the reactants is equal to the total mass of the product. So the total mass of the reactants and the total mass of the product will always be the same, because the total number of atoms present in the reactant side of each element is equal to total number of atoms present in the product side of each element. We now see the chemical equations, how to balance the equations. So a step-by-step method of balancing the equations. So let's see the balancing of equations once again. I already showed you about the nitrogen and ammonia. So I'll take two more examples which are given over here, and then we can discuss that thing later. So the one over here given to you is about magnesium reacting with oxygen to give you magnesium sulfide, so oxide. So it is Mg plus O2. Remember O2Q, because oxygen is always in the form of O2, right? So O2 will give you MgO, that is magnesium oxide. So what we do over here is we are going to find out Mg and O. These are the two elements which are present over here. In the reactant sides, you have got one atom, and product side is one atom. Here it is two atoms, and here it is only one atom. So what we do over here is we will have to convert this 1 into 2. See, I cannot reduce this, but I can always increase this. How do I increase this? By just putting a 2 over here. So if I put a 2 over here, both of them are going to be multiplied by 2 to give you this as 2 and this as 2. So now this part is sorted out. What will be left out will be this part. तो क्योंकि यहाँ पे 2 है तो इधर भी 2 डालना पड़ेगा, तो यहाँ पे 2 डाल दिया. So now what happens is 2Mg, O2, O2. So accordingly, this is a balanced equation. So burning of magnesium oxygen, word equation magnesium by oxygen gives you magnesium oxide, Mg plus O2 gives you MgO. So by balance करने के लिए पहले ऑक्सीजन को बैलेंस किया. So it will be Mg plus O2 will be 2 MgO, and then 2 MgO, Mg plus O2 will give you 2 MgO. So that is the balancing. So 2 Mg plus O2 is the 2 MgO is the balanced equation for this reaction. The next one is the potassium chlorate, that is KClO3. When heated, it is going to give me KCl plus O2. So how to balance this? So we have got three compounds, three substances over here. So we write the three substances. We write the number of atoms in each in the reactant side and in the product side. Okay. So you can see only oxygen is something which is not balanced. Now to make this 3 को मैं 2 नहीं कर सकता, but 2 को मैं 3 करने जाऊंगा, तो उसके बाद what we can do is that we are taking the LCM of both this. Okay, we are going to take the LCM of both this, so that I'll just multiply this by 2 and this by 3. So this becomes 6 and this also becomes 6. But this is connected, so all this will be 2, 2, 2. So ये 2 इधर आएगा and there will be 3 over here. I'll come again. This is 3, this is 2. Because I cannot just convert this 2 into 3 directly by multiplying anything over here. So what I'll do is I'll take the LCM of 3 and 2. What is LCM of 3 and 2? 6. So to make this 6, I'll have to multiply it by 3. And to make this 6, I'll have to multiply by 2. But this is connected. That's why it has to be multiplied by 2 throughout. So 2 इधर आएगा. So K भी 2 हो जाएगा, Cl भी 2 हो जाएगा, and O भी 6 हो गया. यहाँ पे O तो 6 हो गया, but ये दोनों 1 1 है. So I'll have to put a 2 over here to make this into 2 into 2. So this will be 2 and this will be 2. So now this is 2, this is 2, this is 6. This is 2, this is 2, this is 6. And the final reaction will be 2 KClO3 will give you 2 KCl plus 3 O2. This is how you balance the equation over here. They asked us to do 3 sums over here for balancing purpose. So let's go and let's complete these ones. So the first one is HgO gives you Hg plus O2. So you know Hg is 1, over here it's 1, O is 1, here it is 2. So automatically I need to multiply this by 2. So this also gets multiplied by 2 because I am going to put a 2 here. See, I cannot put this 2 over here like this, because if I do put like this, that means मेरा Hg का balance ही 2 हो गया. So I cannot do anything like that. I cannot put any subscript to the numbers. Okay? I have to put 2 as something like this. So now what happened? This is 2, this is 2. So ये 2 हो गया, ये 2 हो गया. But ये 2 है, ये 1 है. So I'll have to put 2 here. So the answer is like this. Let's see next one. 2H2O2 gives me H2O plus O2. So you got hydrogen over here, which is 2 here and 2 here. O, which is 2 here and 3 here. Okay. So again the same way as I told you earlier. So this is nothing but 1 plus 2, because 1 over here and 2 over here. Okay. Now H2 is not a problem at all, so we not touch this right now, but this I will have to multiply it by 3 and this I will multiply it by 2. So what I'll do is that I'll make this as 3. So 6O2. Over here again H has changed, so मुझे यहाँ पे भी 3 डालना पड़ेगा, तभी जाके ये complete H हो जाएगा. So H will be here 6 and here 6, but here it will be 3 plus 2. So again it's not going to be possible. I'll have to try something else. Okay, so this is not happening because here I am getting it as 5, but I want over here O as 6, but here I am getting it only as 5, because if I put a 3 over here, and I cannot put here anything as to make it 6. So possible नहीं है. तो उसका मतलब है कि the 3 what you have put on over here is not going to work. So let's try with 2. If I put 2 over here and 2 over here, this will be 4, this will be 2, this will be 4. So now you can see O is 4, O over here will be 2 plus 2 is equal to 4. See this. Hydrogen is 4. Hydrogen is 4. Oxygen is 4. Over here oxygen is ये 2 है और ये 2. 2 plus 2, 4. Okay, so this is balancing. So answer was 2H2O2 giving you 2H2O plus O2. The next is P2O5 plus H2O giving me H3PO4. Okay, so what we have is P, O and H. P over here is 2, O is 5 plus 1, that is 6, and H is 2. On the other end, P over here is 1, O is 4 and H is 3. So let's take this one first. So of course यहाँ पे मुझे 3 से multiply करना पड़ेगा. Or else first of all let's take P. P over here is 1, so make it 2 over here. When I make this 2, automatically this will become 2, this will become 8 and this will become 6. So now I know that to make this 6 I just need to multiply by 3, so it will be automatically 6. So I put a 3 over here. This 1 will become 3 over here, so automatically this becomes 8. So you can see ये 2 और ये 2 हो गया, ये 8 और ये 8 हो गया, ये 6 और ये 6 हो गया. So you can see P2O5 plus 3H2O giving you 2H3PO4. You can check it once again. 2P here, 2P here. O5 plus 3 is 8. O is 4 into 2 is 8. H is 6, H is 6. So this is how you're balancing the equations. So you're balancing over here one by one. That's the answer for your balancing equation. So this was about the chapter. This was the end of the chapter of language of chemistry. You can see the good amount of exercise examples for the balancing molecule of the word equations are there to give you the normal equation, the symbolic molecule equation, and there are also the practice sums for the balancing of equations over here. So that is very important to practice, right? So that was about the chapter language of chemistry, standard 8th. Okay, thank you.